Good day. In this video, we're going to look at the sine rule and how we can use it to find solutions in triangles. You should know that in any triangle in the world, we name the vertices or angles with capital letters. And if that vertex is called A, then the side opposite him will be called small a. This angle is B, and the side opposite him will be small b. If this angle, capital letter, is C, then opposite him will be a small c representing the length of that side. For the purpose of this video, I would like you to see that in any triangle, we have 6 things. 3 angles, the capital letters A, B, and C, and 3 sides. Now, to know when the sine rule will work on a triangle, there's a small rule that we say, if you can find a packet on your own plus one thing. So you can get all the info to fill in one of these packets plus one more thing of the 6 things. You can use the sine rule. You now see what I mean. So you need to find one angle and one side given to you or worked out by you plus one more thing. So here is our first problem. They gave us this triangle and asked us to work out the length of that side, EF. They gave us that angle, and they gave me the side opposite that angle. Just remember, I said you must sometimes work on your own. Without me asking you, you can also see that this angle plus this angle plus this angle will add up to 180, so I can get this angle size, which I don't need now. To solve this problem, I can use the sine rule. Because of this rule that says I have one of my packets. I have a side and an angle opposite him given to me. I have to work out that side and I have his angle opposite him. I will use the ratios where the sides are at the top because I'm looking for one of the sides. So I'll write EF on top of sine 57, the angle opposite him, is equal to the full packet, 4,9 over sine 69. Now it becomes an equation. We can times by the LCD. Because we have EF at the top, we can just times by sine 57 on both sides. Therefore, EF equals this. And I plug this into my calculator. And I round off my answer. EF is almost 4,4 units. Stop the video and get your brain around this problem. Here is my second problem. They gave us this triangle. They told me that angle is 90 degrees, that angle is 20 degrees, that side is 10 units long, and we have to work out the length of CB. Now I want to see if I can use the sine rule. I can use it if I have a full packet plus one more thing. I have that length over there, but I don't have this angle. But actually I do. I have the 90, the 20, and interior angles of a triangle first. So minusing the 90 and the 20 from 180, I get 70 degrees. Now I have a full packet with a given side and a given angle. Because I want a side, I put my sides at the top. CB over sine 90 is equal to my full packet 10 over sine 70 degrees. To get CB alone, I times by sine 90 on both sides. Then CB equals this. Then I work this out on the calculator. Then you get CB, rounded off, will be 10,64 units. Stop the video and get your brain around this. In earlier years, you learned that if you have a right angle triangle, you could go through SOHCAHTOA and go for the answer. So you could also have done cos 20 degrees equals to adjacent over hypotenuse, which is 10 over CB. Then you can times by the LCD, which is CB. Then you get CB cos 20 is 10. Then to get the CB alone, you divide by cos 20. Then you get CB is 10 over cos 20. Plug this into your calculator and you get CB is rounded off to 10,64. The same as the answer that you got here. Because we now have the sine rule to work with, a lot of people didn't understand this in previous years or forgot how it worked. So from here on, when you get any triangle in trigonometry that you have to solve either a side or an angle, you can use the sine rule in the place of this one. And if you understand this, you can use this on a right angle triangle. And here is our last problem for this video. They gave us this triangle, gave me that angle, asked me to work out the size of that angle, gave me the length of this side, and gave me the length of this side. We have to work out the size of this angle. Because I have a full packet over here, I can use the sine rule. I will start by writing the angle that I want, sine d over the side opposite him 4 equals the full packet. I'm using these ratios now because I'm working out the angle, then I write the angles at the top. Because this is an equation with fractions, I will times by the LCD. Because this sine d is at the top, I'll just times by 4 on both sides. That will give me sine d is this. I will put this into my calculator and get sine d is 0.59. I will not round off, and I will store it in one of my memories of my calculator. I just rewrote this part up here. Now to solve for d, I will use my calculator again. This step you can leave out, but just if you forgot how to work it out, you'll push Shift, Sine, Recall A, and then get the answer for the size of angle D, and I'll round it off to however many places. I went for one place, so it's 36.5 degrees is the size of that angle. And then we fill it in on our sketch for in case we need it further on. Please stop the video and get your brain around this problem. Just one more fact. There is an ambiguous case involved with the sine rule. Ask for it if you want to know more. Please indicate whether you liked or disliked the video and subscribe to the channel. If you do run into a problem solving triangles in trigonometry, you may send a clear WhatsApp picture of your problem to this number and a clear WhatsApp picture of where you tried it. Then we will try and solve the problem for you and send back an answer as soon as possible. Enjoy trigonometry.